This is Juan Carlos. My PI ID is 6229898. This is electronics 1. I'm doing the second lab. I'll show you guys right now the basic differential amplifier and zoom-in amplifier. So here I have my design here. I have the three op amps here, 1, 2, and 3. This is the design in multi-sim. So I connected the first one vertically, like I put it on the breadboard. This is the first one, this is the second one, and this is the third one. So I have it here, 1, 2, and 3. This right here is the line for the power supply. So the wire is going to, I'll explain the pin out right in a few. This is it. And this right here is the terminals for the negatives, the ground, and the positives, the 2 volts. Since both of the amplifiers are using the same power, I connected to the same port as shown here. This is the one that I chose. This is the first one from part A, with the voltage are the same. All the resistors, yeah, they're different. This one is identical than this one, and this one is identical as this one. And the 15 volts of the power supply. I get 15 and 15. So here I showed a mathematical approach. I have the circuit here. I did circuit analysis. We can see here that this node right here is the same as this one, so it's the same voltage. And the current here going to this resistor is the same as the one going to this resistor. So we just apply the nodal voltage analysis from here to the second input power, and then from here to the other power. And I figured that is equal to this right here. This is the final formula for the V0, which I used to plug in all the values that I used, all the resistance values and the voltages, and I get the same value as expected. It's 14. I don't know, my system is a little weird. All the icons are pretty small, but so that's part 1. The other one for part 2, well, I base all my connections on what is it right here on this diagram. This is the pin out of the 741 op amp. So pin 1 and pin A, I didn't connect them. Pin 7 and 4 they're for the power supply. 2 and 3 are the inputs. 6 is the output. 5 I didn't connect it as well. For the second one, I used, this is the circuit right here. I put it on a different breadboard. I had it before having it here in the green one. I had it here, like down below, since I was using the same power supply and same voltages here. The voltage that I was providing to this circuit here got split in between 2. So I needed to move it here. So that's why I moved it here. So we have the op amp here. All the resistance values. These 2 resistors are the ones here. These 2. So I connected the power supply. The input voltages from here and from here, as you can see here. Where is it? A little hard to see, but it's here, and the other one is the black one. And the pin out. The pin out. It's easier to see. So the power supply values from here, the same one's going to the other circuit. I connected them to the 15 volt plus and the 15 volt negative, respectively. This one right here, which is the positive side, which is the 2 volt, connected it to the plus 1. The analog output 1 on my DAQ. And the same for this one. This is the analog input. The green one is the ground. The ground. And the white one is the plus 1 to the pin 6 in the first circuit. So that's we were trying to calculate. That's V naught, the white wire and the green wire. Same V naught here. It's the same one. I have it here, and the multi simulating design is the same one here. That's where I have the multimeter. And for the second one, I didn't show that. This is the circuit in multisim, and those are the same values I calculated. I used the setup for part A in the second part, in part 2. So the one that is using both voltages are the same, and all the resistances are the same. So it gives me a -3 volts. So when I use them, when I actually run the setup here, the physical one, and I use my the AQ and the multimeter built in, I was able to get all the values correctly, the same one as I calculated on multisim. So this one was for the first one, which is minus 14.93, which is the same one as for this one. So that was pretty good. It was off by 0.8 volts, which is quite big depending on the application. I wasn't sure why that happened, but the thing is, for the second circuit I got -3.997, and for the second part I didn't get any off readings. This is the report, by the way. Look, 39939. So yeah, for part 2 I didn't get any off results, just for part 1. I'm not sure why. And let me show you the math for part 2. It's right here. So same as before, same voltage here, same voltage here. This node is the same as this one, so just apply the node voltages and work into this. And then when I plug in the values, it comes to be the same one as this one. Alright, so that was all for lab 2. This is the one that I'll be using for my individual lab report. So I attach all the pictures and all the readings and all the screenshots I took and all the math, of course. Alright, thank you.